Hello everybody and welcome to this GCSE Chemistry explanation video about alloys as useful materials. In this video, we'll start by looking at what alloys are, and then from there we'll move into examples of alloys that you need to know about for your exam, and then we'll explore the properties that these alloys have got that make them useful for a particular job. Most of the metals that we use in everyday objects are alloys. And an alloy is a mixture of two or more metals, or it can be a mixture of one metal with some non-metals mixed in. And the reason that we do this is once we get the mixture, the properties of the metal change. And so, for instance, pure metals might be more malleable or softer, and the alloys that we produce could be harder or more resistant to corrosion. And so scientists mix together the metals and they create an alloy that has got the properties that they want. To understand why pure metals have such different properties to the alloys that we can make from them, we need to look at the structure that they have. On the left-hand side here, we've got pure metals, and the pure metals you can see have only one type of atom. That's what we mean by pure. And as a result of this, these atoms of the metal are arranged in nice rows. And these rows are all very regular, and that's because all of the atoms are the same size. And so because these rows or layers are so regular, if you were to hit them with a hammer or press them, you can change their shape. And that's what malleable means. You can change their shape without breaking them or cracking them. And that's also what makes pure metals very soft. In contrast, for an alloy, you've got your original metal, but you've also got at least one other type of atom. And crucially, as you can see from my picture, this second atom is a different size. It's not always smaller, sometimes it can be a larger atom. But as a result of the atoms that are now present in this mixture all being different sizes, the layered structure has been distorted or disrupted. It's certainly no longer regular. And so as a result of that, there aren't really any layers, and so the atoms don't slide past each other as easily as in the pure metal. And this then means that they won't be so malleable. They will in fact be much harder than pure metals and be less easily shaped. And the precise proportions that you have for the alloy, in other words, how much of this extra element do we add compared to the original element, that will influence the properties that the alloy has got. For instance, the larger the proportion of this second element, the harder the alloy is likely to be, the less easily it will be shaped, and that would make it more suitable for a particular use. Copper ores, like all metal ores that we extract from the Earth's crust, are finite, which means that they are running out and being depleted over time. Copper ores in particular are running particularly low. In fact, it's considered that the amount of high-grade ores that are available to us to extract the copper are pretty much all depleted, and so now we are using lower-grade ores as our source of copper. So that means we've got rock that we're digging up from out of the ground that has got a much lower percentage of copper in it. That's what we mean by a low-grade ore. And so as a result of that, copper is becoming more scarce, and so it is getting very expensive. And that's one of the reasons why we choose to not use pure copper, but to use it as an alloy. Other reasons are that we change the properties by converting the soft pure copper into an alloy. Two alloys of copper that you need to know about are bronze and brass. Bronze is an alloy where we mix tin in with our copper. Bronze is much harder than the copper would be as a pure metal, and so that makes it useful for things such as statues that need to stand the test of time, and also decorative objects such as medals. Brass is a bit more malleable than bronze, and that's an alloy of copper with zinc. And because it's more malleable, it's useful for applications that require moving parts. So, for instance, in taps and door fittings such as hinges and door handles and screws. And it's also useful for ornaments and musical instruments. Aluminium is an incredibly useful metal because of its low density. And a low density means that if you had two objects that were the same size, one was made out of iron and the other made out of aluminium, the aluminium object would be much lighter because it is low density. But as with a lot of pure metals, pure aluminium is too soft for some of the things that we would like to use it for. And so what we do is we mix in small amounts of other metals, and that makes the aluminium alloy much stronger and more durable, and also usually more resistant to corrosion. And so then we can use our low density aluminium alloy to make all sorts of things, often in the transportation industry, so things such as aircraft, spacecraft, cars, and even ships as well. All of those are really useful to capitalise on that low density and resistant to corrosion. Additionally, because it's a metal, it will conduct electricity, and because it is low density, the aluminium alloy can be attached at the top of tall pylons without the risk of it breaking under its own weight. One of the most common elements to be converted into an alloy is iron, and when you make an alloy out of iron, we call it steel. Specific amounts of carbon can be added to iron, and that can make a type of steel referred to as high carbon steel, or we might mix in other elements such as chromium, and that might make stainless steel. And you need to know about the different types of steel and what properties the alloy has and what uses that makes them suitable for. And there are three that you need to know about. The first two are both called carbon steel, but if you vary the proportions of carbon that we put into steel, that gives the steel dramatically different properties, which makes them suitable for their uses. For instance, low carbon steel has got quite a low percentage of carbon being added to that iron. And as a result of that, the layered structure of the iron is not very disrupted. And so this type of steel is quite easily shaped. And as a result of that, it's useful for things such as car bodies that need to have an intricate shape to them. High carbon steel has got a greater proportion of carbon added to it, and as a result of that, the layered structure of the iron is more disrupted, and so that makes the steel far less flexible. You probably refer to it as being brittle, in fact, it's inflexible, and it's also quite a lot stronger. And so we typically use high carbon steel for things that need to be very strong, such as bridges and knife blades and cutting tools. If we add something such as chromium or nickel to our iron, we get stainless steel. And this, as all alloys, is harder than pure iron is. But not only that, the presence of the chromium and the nickel make the steel corrosion resistant. And this makes it really useful for cutlery and containers that need to hold substances that perhaps are corrosive. And this makes really good sense as being useful. If you think about how we use cutlery, we need to be able to eat with the cutlery, so our mouths have got saliva which will be water-based and slightly acidic, so it's really important that the cutlery doesn't react with water. And additionally, we need to wash up spoons and maybe leave them to dry on the drainer, and so it's really important that they don't corrode or go rusty very easily. And some types of steel, and certainly pure iron, can definitely rust very easily. And so you can see that we can vary the proportions of the elements that we add to the iron to make it have dramatically different properties. And as a result of that, we have dramatically different uses for the different alloys of steel. The objects that we think about as being made from gold are often actually made as a gold alloy. And that's for a few reasons. Firstly, 100%, in other words, pure gold, is quite soft. And that's because all of the atoms are the same size and the layers therefore can slide over each other. Additionally, gold is very rare and so it is quite expensive. And so to make jewellery as an alloy, we take our pure gold and we mix in some of a second metal, for instance, silver or copper or zinc, and sometimes a combination of more than one of those. And what we get then is some jewellery that has got similar properties, but is significantly cheaper. And the alloy will definitely be harder, and that will allow the gold that is produced as an alloy to be a bit more durable and robust. It can also be used as a preference because it does change the look of the gold depending on which of those additional metals we add. For instance, adding silver definitely makes a lighter gold colour. Pure gold, as well as sometimes being referred to as 100% gold, is sometimes referred to as 24 karat gold. And this carat system is a decreasing number down from 24, where that number can be used to work out how pure the gold is. So, as I've said, 24 karat gold is 100% pure, and so half of 24 is, of course, 12, and that would be 50% pure. And in an exam question, you might be asked to work out the purity of, say, 18 karat gold. And what you would have to do is you'd have to express that as a fraction. And so 18 out of 24 is 75%. Or 6 karat gold is 6 out of 24, so 25% pure. Or 8 karat gold is 8 divided by 24, so 33 karat gold. That proportion system is definitely something that you need to be able to be flexible and think about in an exam situation. Exam questions about alloys can take a few different approaches. Firstly, you need to be able to recall a use for each of the alloys that we've covered in this video. Secondly, you need to be able to be flexible and think about properties that an alloy might need to have for a particular job. And so you would need to think about what the job this alloy is going to do would require. And so it might require a material that has got a low density, or maybe one that is particularly hard and rigid. Or it might need one that is resistant to corrosion. You need to be able to adapt to the situation and make some suggestions. And so that won't be something that you've been taught. You'll be asked to suggest a property that it might need. Or you might be presented with some data, and from that, maybe a pie chart or a graph or something like that, you might need to work out the percentage by mass for a particular element in an alloy. Or you could be given a data table that's got some details about the different types of bronze, type 1 and type 2. And one of them is 90% copper and 10% tin, and the other is 70% copper and 30% tin. And they could ask you some questions about this data table. They might say, which of these alloys would you expect to be softer? And that would be the alloy of bronze that has got the greater proportion of copper, because that means there'll be less of the atoms of tin, and that means the layers in the alloy will be less disrupted, and they'll be able to slide over each other more easily. Or they might say, these two alloys have got different melting points. Suggest why. And that would be because of the different proportions of the metals, or the different percentages of the metals. Or they might ask you a data handling question, and they might say that bronze type 1 is used to make an ornament, and the ornament has got a mass of 2,400 grams. What would be the mass of copper in that ornament? And you'd have to look at the table and say, right, well, this type of bronze is 90% copper, and so we need to work out what 90% of 2,400 is. And there's a few different ways of doing this, but the best way is to represent 90% as a fraction, so 90 divided by 100, and then multiply that by the mass of the ornament, which is 2,400, and that gets us a mass of copper of 2,160 grams. Okay, that's the end of this video. I hope it was useful. I'll see you again soon.